Hello all, my name is Code Eric, and I'm back here with another demo. We're going to talk about the Z API today, and we're going to be continuing to demo Zerv. So first thing I want to do is I want to show you back on the app what it's like to add a server connection. So this is going to be a really useful capability. You can see basically from our demo on yesterday, we have a dev server that we're connected to here. And we can go into here and look at the server connection. You can see, look at the server connection, see the URL. We're on the local server here, and it says that we're connected to the server, which is great. So let's go into the app settings and the server connections. I'm going to add a new connection. I'm actually going to add the dev server, which is kind of the only currently deployed Zerv server right now. It's at https dev.zerv.app. That autocomplete drives me crazy, or that auto capitalize. Okay, so now we've got the dev server, and it says that we've connected to the dev server. And now that we can see on our home screen, we've actually added a section for the dev server. And it even has data that's actually on the dev server. So here's the banner on the dev server. But mostly what I want to do is I want to show you the dynamic API that's available inside the dev server. It's really cool. So what does that look like? So inside of the server setup, there's a little button here for the dynamic API. Now, what we're looking at here is actually the raw API of the server. And it's cool that we're looking at the remote server for the dev server, but I'm going to actually take a look at our local API, so that way we can make changes to it. Like I said, it's dynamic, so it's going to be changing. Here we have our API. This is exactly what our API is. And if you look at the source code here, you can see that the Z root, which is the very main sort of point of our API here, it's our main entry point that we pass into start Z server, where we're also providing the port, so that way the server knows how to start up, knows where to listen. So a Z container is basically just a folder. It's basically just accessing store and admin. And that's exactly what we're able to access here on our UI. And each of these are also Z containers, and that's why they have this little icon, right? So we can see that admin is a Z container here. But we have a bunch of stuff turned off, right? So we can turn on the test ledger by just commenting it back in. And the test ledger is a special type. It's considered a Z type. That's why there's this Z in all of these things. But I'm going to turn on the test ledger, come back over here and hit reload. And now test ledger is available, as well as whatever behavior is available beneath it. So because test ledger is a blockchain, it has the ability for me to see the current state and also call actions on it and dispatch new actions. So let's take a look at admin though. Admin, you can see, has access to data as well as an SMS and an email thing. So what is SMS and email? We'll go back into, we'll go to admin, and you can see that SMS and email, they have little play icons. So these are actions. So we can see, for example, let's take a look at the implementation of SMS. So SMS is an action. It's create Z action, create Z action. And what we're doing here is we're specifying the type that we're going to send in to an action. So this is a JSON schema. It's a raw schema that we've specified inside of our code. And it says that we need a phone number and a message, right? So the message has to be of type string, and the phone number matches the phone number schema, which we have up here. So let's take a look at the SMS section here. Okay, cool. So you can see that this form is being dynamically generated from our schema here. And just to really let that sink in, what I'll do on the phone number schema is I'll add a title, phone number. So right now on this toNumber field, it says it's a string. So if we save this, and we can also add a description where to send the text. Now we come over here and reload, and we can see that our schema is updating. We can see that from here, where we're actually implementing our action, we're able to adjust the form of when the action gets sent. So I think that's pretty cool. That all we have to do is we have to create this one Z action, and the entire UI, including type safety, gets exposed to the client. And of course, you can do this action. I'm not going to punch in my phone number here, but maybe we can send a quick demo email, right, and see what it looks like. Message is hello test. Subject is my subject. This is really bad content. Eric@zerv.app. Please don't spam me. Hit send. And we're having some, oh, it was just really slow. There's supposed to be a spinner that shows up that shows what that looks like. But here it successfully worked. It's not giving us very detailed information here, but fine, let me check my email. Yep, okay, there it is. You'll have to take my word for it. So the server actions are dynamic, and so is the data that's available. So this data container contains all sorts of other things, and this docs in blocks represents the actual low-level data inside of our application. But we're going to get to that later. I want to talk all about how the database works, but this is not the episode because we're just talking about how easy it is to create a dynamic API that has a user interface generated for it. But let's go and turn on some of this crazy stuff that I've built. These are things that you really shouldn't have on a public web app, but you know, I'm breaking some rules right now. So we're back in admin. I'm going to come and reload, and we can see we have some of these new things. Like we have, like, what is root files? Okay, root files is a bunch of actions, and it's actually giving us access to the root file system of my Mac. So this is like pretty crazy. But like, for example, if we read dir, and if I type in like the path like slash, you can see, okay, these are actually all of the files that are in the root of my of my computer. And there's even the ability to like delete and whatnot here. But even more fun than that, I think, is the ability to, SSH we'll get to. SSH I don't have working right now, but the commands are fun. So here we can do a single command. For example, we can ask the computer like what the uptime is. Uptime is a fun command that doesn't have any arguments. So we can see how long my Mac has been running. And here we could say that the Mac says that it's been up 13 days. Okay. 2 weeks since I've rebooted this MacBook. Pretty nice. Okay, so I think you get the idea. I think you can see it's kind of fun. Thing is, it's April Fool's Day, and I just got my server up and running. Basically, this is the first time the server has ever worked. The first day the dev server has ever worked. And so here's the thing: I want to troll my server. Like, you know, of course we can do this boring stuff. We can create a new file, and it shows up on the dev server. That's all great and interesting. But here's the thing: is the server is exposing some scary stuff, and I want to screw around with that, right? So we can see if we have sudo access, for example, on our server. Here we're able to come into our commands, and this isn't my server. This isn't my computer. This is a cheap server that I'm very willing to destroy. So who knows what we want to do? We can do sudo. Let's just do sudo touch, and we'll touch something that's like at the root of the. We'll just try touching a file that's at /file.txt. And what this should do is it should run sudo on the server. Okay, it says the network request is failing. Now I've not really done this. This isn't really a good idea. Okay, this is what the server is actually sending back to the client. It's telling us, it's giving us the sudo message. It's saying that we need a password for sudo. So on our server, we're not actually running as a sudoer. We're running as the Zerv user. So, okay, just for fun, just bear with me for a second because like we're gonna have some fun with this. I'm gonna go into the server. Let's see. And I'll come over here and we'll do vsudo. And this allows me to edit all the sudoers on my server. Let's see. I want to say that Zerv user has access to sudo without the password. Okay, so I'm going to write this file and quit out of here. Okay, so now let's see if we run this again, if it succeeds. Okay, so it did. It did a sudo. It touched. It has an output of nothing. So that means we're able to run sudo on our server. And just to verify that we actually created file/txt, let's go back to the files and we'll read directory. We'll read directory / to make sure that our new file is there. That will give us some confidence. Yes, okay, so we're really running as sudo on our server. This is a terrible idea. And because it's April Fool's, I think what we're gonna do is we're gonna troll the server. We're gonna just delete it. We're gonna see what happens when we run rm-rf star on this whole server. So we're going to come into the commands. Oh, my heart's beating because like we're about to destroy this server so bad. Sudo, and then we're going to type in the array argument here, and we need 3 arguments. rm, this is the command that deletes things, -rf, this recursively deletes everything, and it forcefully recursively deletes everything. And we want to say what we're deleting, which is slash, the whole server. Slash is the very base path. This is going to be interesting. All right, sudo rm-rf slash. Let's see what happens, folks. All right, it says the network request is failing. Let's see why it claims to be failing. Use -- no preserve root to override this failsafe. Wow, it's built into rm-rf. That's fun. That's so fun that we have to come in here and manually add an additional flag that we're allowed to do, from zerv. Zerv just allows us to pass an argument array, including into our sudo command. So rm-rf slash with no preserve root. I love how this builds the suspense. Okay, I just hit play. It says it's failed. Okay, standard error, max buffer length succeeded. So apparently it's tried to output a bunch of info into the standard error. So let's see if the server is still up. It looks like the server is up here. And even if we hit /z, yes, the API is still online as well. So that's it, folks. You heard it here first. Our server is incredibly resilient to rm-rf star. But the Z API allows you to expose an API on the server of arbitrary depth and complexity and still consume it with a type-safe front end from the Zerv app. So I hope you enjoyed this demo, and I'll see you again in the next one.